Yeah, hello everyone. Now let us look at what is called what we are going to look at is the multivariate data visualization using the ggplot2 in R, okay, the ggplot2 package. Now previously we have had a look at univariate visualization using the ggplot2 package. We've had a look at the bivariate distribution using bivariate visualization using the ggplot2 package. Now we want to look at the multivariate data visualization using the ggplot2 package, okay? And when we say the multivariate, we are looking at we have 3 or more variables, okay, in plotting on the same chart, okay? So let's get to it. So previously, if you were not here, these are the different data visualization which was actually observed in terms of the bivariate distribution, okay? So let me clear this. Now you are going to perform the multivariate distribution, and what I would ask you is, again, if you go to the, you can actually copy all the codes on the multivariate distribution, and then you can go ahead and then paste it in R and follow along whilst I explain each line of the code, okay? So first of all, we can load our data set or import our data set. So let us import the data. So this line of the code actually allows us, once we run it, there's a dialog box that opens up. We are able to select our data set and then go back. Okay, so now our data set have been loaded and now ready for use, okay? So again, we can actually have the names of the data, just to know the names of the data set. And then we can actually also attach the data set. Once we attach it, we will then have to use a $sign to call a variable anytime we need it. And then we can also observe the summary. Again, there are negatives in the data set, so we have to clear the negative by using this line of the code. So we are going to create a new data set from the original data set, okay? By using, so with a square bracket and with the concatenate function, we are creating a vector of different variables within which we are going to clear all unwanted information, which might include the negatives and then non-response and others, okay? So it's better you always understand your data and then you look at it also from the code book to ensure that whatever value you are eliminating is a right value, which is actually indeed not needed in your data set. But now we do that and bring within the square bracket, we bring comma. So we are also asking R to give us every single column thereafter. So although we are only looking to clean only these particular variables, but we also need all other columns to be within the new data we are creating, okay? So we go ahead and then let's run that line of the code. So once you have run it now, we can go ahead and then look at the names, still the same names as before, okay? And then now you can go ahead and attach it. Again, attaching it to ensure that we can call the variable without having to initiate using the $sign in the data name, okay? And then we can get the summary of the new data in which we clean. So basically those variables in which we clean, if you look at them, you can see there are no negatives in those variables as compared to earlier on when the statistical summary was showing some negative, okay? So now, so for instance, if we have a summary of this quality of care, currently R is seen as a continuous variable, but it's actually a categorical variable with 5 levels. But for R to see it as a categorical variable, let us find a summary, and then we use a function called the factor function, okay, the factor of that variable, which is quality care, and that allows R to know it as a categorical variable. So now we have it we are able to see that, okay, these are the different levels and these are the number of count for each of those levels. But then again, this is not meaningful enough because what does 1 represent, 2, 3, 4, 5? It's not meaningful. So for us to ensure that it becomes meaningful before we proceed to generating our plots, we actually want to give it an ideal name, okay? So we'll go into the data set and then create a new variable, which we are calling quality of care new _new, which is a new variable we are creating from the old variable. But what we are then saying is that within the data, go pick up the quality of care, which is the old variable, and for every value equal 1, assign it to what? Excellent. For every variable equal 2, assign it to very good, and so on and so forth. So all the way to what? Poor. So we can run all this line of the code or each line of the code. So let's run it. So once we have run that line of code, we can go ahead and then look at the summary, which gives us a new variable that have been added. And then we can go ahead and then attach that variable to ensure that now R is able to read that variable directly. And then we can take the summary of the new variable we created, but then we are saying that that variable is a factor, okay? Now, without using as a factor, R wouldn't be able to read it as some character, okay? But once it's a factor, R knows it's a categorical variable and it's able to give you the levels and then the number of counts. Okay, so here's what we have. Now let us proceed with our multivariate visualization. So first of all, what we actually want to do is we want to create a bar plot, okay? So we are going to create a bar plot of the distribution for BMI by quality of care and then the gender of the individual, okay? So we are looking at it by quality of care and gender. So we go to the ggplot, we call our data, which is the hints data, and then we use the static function. The x-axis, we want the x-axis representing the quality of care, which is the levels. And then we want the y-axis representing the BMI, okay? And then we are going to fill each of them with what? With the gender. So now, because we are using the fill, whenever you are using the fill and it's a categorical variable, you have to tell it, you have to use the factor for how to recognize that that variable is a categorical variable, okay? And that allows us to be able to observe the gender within each of the quality of care by their BMI distribution, okay? So remember, these are 3 different variables which are now being observed from the data set: quality of care, BMI, and then what? Gender. So we use the geom_bar, which is the function that is going to be used within the ggplot. Again, for bar chart, we have the star equal identity, and then we want the position. We have a position in order to actually allow us to be able to get these 3 different variables. We want a position which we want position equal position _ dodge, okay? Then plus scale _ fill _ brewer, which we are going to choose what we have what is called the palette pairs, which allow us to be able to actually use these different, project those different genders by the quality of care, okay? So, and then we have the labs, okay? The labs, we have the title, we have the quality of care, and then we have the BMI, okay? And then now we want the color to be what? To be by gender, because that's what we have over the fill. Remember, we said the fill, you are filling it with what? The Bev gender variable, okay? Yeah. So remember, if we have to look at the names of So these are the different names in which we have. So we have the birth gender, we have the quality of care, and then we have also the BMI, which is the new variable within the new variable we created under the hint data underscore new. Okay. So now let us highlight everything and then let's run it. Okay. Yeah. So now you can see that we are able to, you can zoom it. Now you see that we are able to observe the distribution of BMI in terms of the number of frequency of BMI by the quality of care and then gender. So now for excellent quality of care, we are able to observe for male and female in terms of their frequency. For fair quality of care, we're able to observe male and female in terms of their BMI level. For how do you call it, for good, we are able to also observe it, and so on and so forth. Okay. And then you can see, basically, you can see that very good happen to have the highest frequency for both male and female in terms of the how do you call it, in terms of the BMI level. Okay. Okay, so let us continue, and then now we can also have a different example, which we are going to create our own data. Okay, so let's create a data in which we are naming it as df2. So remember, whenever you are creating a data, you use the data frame, and we are creating a data with a name. We have the supplement underscore type, which we are actually going to have it to be to replicate, which is we have C, V, and then OG. Okay, and then we are going to have for each of them, for CG and then OG, we have 3 for each of them. Okay, and then for doses, we are also going to replicate the doses, and the doses we are going to have D 0.5, D1, and then D2, and we're also going to have 2 of them. Okay, it is going to replicate it twice. And then we have the tooth length. So for the tooth length, these are the tooth lengths in which we have. Okay, and remember, each of them, you use the concatenate function to create that vector within the data frame. So let's run that line of the code to create our data. And now we can look at the head of our data set. So basically, this is our data set. You can see that there's VC and then OG. It replicated 3 times each. And then also the doses, it also replicated each of them 2 times. And then we have the different tooth length. Okay, so from here, we can actually create what is called a stack plot with multiple groups. Okay, so in order to create the stack plot, we are actually going to have, again, the ggplot function. Now we have our data. We are going to use our data equal df2. And then with our aesthetic, we are going to have our x-axis to be the dose, our y-axis to be the length of the tooth. And then we are actually going to be able to fill it with what? The supplement type. Okay. Now again, to get the bar plot, we have the geo underscore bar with the star equal identity. And then now we can label our plot with the title, comma, with the dose, with the x-axis, which represent the dose, with the y-axis, which represent the tooth length, and then with the color, which is representing the supplement type, which in effect is going to give us a legend like this, which is showing the different supplement type. Okay, so this is actually going to project a stack plot that allows us to be able to assess the distribution of the distribution of the tooth length by the dose and then the supplement type. Okay, let's run everything. Okay, so now we are able to actually see it, and this is a stack plot. The initial one in which we actually plotted was kind of a cluster plot. So there's a stack plot which we have actually. So this one was a cluster plot. We have this one being a stack plot. Okay, so now we are able to observe for D 0.5, D1, D2, which is the dose type. We are able to observe the supplement type for each of them based on their tweet length. Okay, and basically, you know, I mean, in terms of the highest numbers we have, in terms of the percentages or the frequencies, we have the D2 having the highest number for both the OJ and then VC supplement. Okay. Okay, all right. And that can actually ideally be observed here. You can see D2, the truth is what, 33. And then, I mean, with D2 again, we have the truth to be what, 29 here. Okay. Okay, all right. So we have also another, we can also plot a different style of what? Cluster bar plot, okay? So with the same data, we can actually have a cluster plot of the same data, okay? And to have a cluster plot, we're actually going to be able to use the position and the position in which we are actually going to have is our position underscore dodge, okay, in a parenthesis within the geo underscore bar function, okay? So we have the ggplot, we have our data. Again, we have the dose, we have the y-axis, which is the tweet length, and then we have the x-axis, the fill, which is the supplement type. And then we have our labs. So the only thing that actually changes within the geo underscore bar function is the addition of the position, which allows us to be able to observe the cluster. Okay. So let's highlight everything and then let's run it. Okay, so here's what we have. So now we are able to observe the different, the levels of the tweet length levels, okay, for the different supplement type, okay. And then basically the supplement type for those D2 happen to have the highest tooth length for both the supplement type of OJ and VC, okay. And then D 0.5 have the least, okay. Okay, so we also have what is called the faceted scatter plot, okay? So which is a scatter plot, we are going to show a scatter plot of age versus BMI separated by smoking status, okay? So in other words, we are going to be able to show a scatter plot which is showing age versus BMI. With BMI, of course, if before you plot the scatter plot, again, you ask yourself the question, which of the variable have to be dependent variable, which of the variable have to be the independent variable. The dependent variable is the Y variable, the independent variable is the X variable. And we can say that BMI depend on age, right? So in other words, age could potentially be a predictor of BMI, right? So you have the BMI as our Y variable, the age as our X variable. But then we want to do that also looking at it separated by the smoking status within the plot, okay? So we are using the Hines data, okay, the Hines clean data. So we use the ggplot with the Hines data underscore new with our aesthetic, which we are looking at what? Age as the X variable, and then we are looking at the BMI as the Y variable. And we have geo points, okay? So the geo points is what actually allow us to be able to proceed with visualizing the scatter plot, okay? The geo points, so within the geo points, we also want to, within the points within the scatter, the points within the scatter plot, which has the gender and age and BMI, showing the relationship between age and BMI, we want you to indicate for quality of care, okay? So we have the color equal factor. Now remember, quality of care is a categorical variable. So the color within the point, the points within the plot should be colored by identifying the quality of care, the different levels of quality of care, okay? And now this allows us to be able to actually, so we said that facet underscore wrap by what? The quality of care. So with this approximate sign and then quality of care within this facet underscore function actually allow us to be able to further display this plot and identify the points based on the levels of quality of care. Again, so we have the labs, which we have the title, which gives us the title of our plot. The x-axis is the age, and our y-axis is the what? Is the BMI. And then we have the color is going to be the quality of care. And then we have a tune, which is what? Minimal, okay? Which is going to be a different tune as compared to this, okay? So let's highlight everything and then let's run it. Okay, so here we can actually visualize it and see. So this one is actually able to give us the distribution of age versus BMI for each of the levels of quality of care. Okay, and then you can actually see. So you'll be able to know that what is the distribution of age and gender for excellent, what is the distribution of age and gender for very good quality of care, and so on and so forth. But I mean, to read this particular, there is no a clear relationship between age and gender for each of the levels of quality of care. So I might say maybe there's kind of a very weak relationship. And even it's hard to observe whether the relationship is positive relationship or negative relationship. Okay. All right. So now we can actually look at a different example, which perhaps will give us a clear visualization. And we are going to do that using the MCAS data, okay? So we are going to, which is a built-in built-in data in R. So which is inbuilt data. So we load that data set. And then now we can actually, if you want to look at the names within the data set, we can actually look at the names. So the name empty cars. Let's look at the names in the data. So these are the different names in the data, okay? So what we are going to do, we are going to plot using the ggplot function. We are going to plot the MPV versus horsepower, okay? The MPG versus horsepower separated by the number of cylinders, okay? And the number of cylinders is a categorical variable, okay? So again, within the ggplot, we bring our data, and the two variables we are actually going to plot is the horsepower versus the MPG. So we want to know whether there's a relationship between the horsepower versus MPG. But then within the points, so geo points, now we are plotting the scatter plot, but within it, we actually want you to identify each of the number of cylinders, okay? You have to identify the points by the number of cylinders. So we have the aesthetic. In it, we have color equal factor, which is the what? Number of factor means now we are making our understand the cylinder is a categorical variable, okay? And of course, the cylinder, you can actually see the cylinder. We have the cylinder being a category. So you can say summary. You can have the summary of the factor of empty cars. So we can use the $ to be able to see. And then now let's run the summary. So you can see we have we are looking at 4 cylinders, 6 cylinders, and 8 cylinders. And the number of 4 cylinders is what, 11, the number of 6 cylinders, 7, and the number of 8 cylinders is what, 14. Okay, you can also observe the dimension of this particular data, so which is empty cars. We give you the number of rows and columns, which is we have 32 rows and 11 columns. Okay. Okay, so now, so given this, we can go ahead and then run this line of the code. So now we are able to actually observe. So we are able to observe the relationship between MPG and then the horsepower for 4 cylinders, for 6 cylinders, and then for 8 cylinders. Okay. Now for 4 cylinders, basically you can see that 4 cylinders have higher you can see that have higher MPG and lower horsepower, right? And then you can actually also think about 8 cylinders tend to have higher horsepower and then lower MPG, okay? And then with 6 cylinders, it's basically almost within, the middle, and we are actually able to observe, perhaps maybe there could be some kind of negative relationship between horsepower and then the number of cylinders, okay? But now we are able to observe them based on the different type of cylinders. Okay. So now we can also proceed to further customize and create a more aesthetic scatter plot, okay? So using our hens data set, we can actually create a plot of age and BMI, again using the zoom function. We are actually going to create, we want you to identify by the plot. We want you to identify the plot, the colors of the plot by the gender, which is male and female, and then also create within it, also create the shapes by the smoking status of the individual, okay? And then make it, the size is what, 4. So in other words, now we are going to have 4 different variables within the same plot with same scatter plot. So first of all, we are plotting age versus BMI, but within it, we are able to identify the gender, which is male and female, and we are also able to identify by the smoking status, okay, which is current smoker, former smoker, or never smoke. So now we can now proceed to use the scale. So this line here actually allows us to get our scatter plot with the different points within the scatter plot. Now we have the scale underscore color underscore manual to be able to now get the values. So we have, for each of the values, we want it to represent what? Blue and red, okay? So we have blue and red. And for the blue and red, we are giving it the labels to be male and female, okay? For the blue and red color, okay? Remember, the color is representing male and female, okay? And now we say that, okay, we want you to give it blue and red. And blue will be male, red will be what? Female. And then another layer of the plot is we want you to also, we have scale underscore shape underscore manual also give us values equal, 16, 17, 18. And that actually helps us to be able to get the different shapes. Now, we are going to get 3 different shapes that is actually going to display for the smoking status, okay? Now, with the labs, which is as usual, our title, which is the distribution of age versus BMI by gender and then smoking status, with our x-axis representing age, our y-axis which representing the BMI level. The color will be the gender, and the shape is going to be the what? The normal smoking status. Okay, so we have the team underscore classic, another layer which add more beauty to our plot. And then also team, which we are going to have plot dot title equal element underscore text. Okay, which also give us a more further beautification of our plot. So let's highlight everything and then let's run it. So we can look at it, can zoom it, and now we can see. So circle is representing smoking status 1, triangle smoking status 2, diamond smoking status 3. And then for gender, blue is male, red is female. So now we are able to observe the relationship between BMI level and age based on gender and then what? The smoking status. Okay. Now, next, for a more clarity, because again, if you have a huge data set, sometimes the visualization can look quite messy, okay? So maybe let us get a less data set that allow us to be able to get a better visualization as compared to the current visualization. So we are going to use the empty cast, okay? So again, with the empty cast, which we have, these are the names of the empty cast. We are going to look at it by visualizing the weight of the car versus the mpg, which is the mass per gallon. And then we are actually going to create the points by coloring the points based on the MA. And then the MA is actually going to be the transmission. And then the shapes is actually going to represent the number of cylinders, okay? And then again, we have size, 4 size, the values over here. So with this layer, which is a scale underscore color underscore manual, allow us to denote the transmission, which is the MA, by blue and red, okay? But before then, you have to be able to know what is the number of levels of the MA, okay? Which you can actually be able to simply find a summary of the factor of MA, and that gives you 2 levels, okay? If it is 3 levels, it means you need to add an additional color. Okay, so we have 2 levels, so we are giving it red and blue and red. And then we have the manuals also. So we have the manuals, which is for the blue and red, blue is going to be the automatic and red is going to be the what? The manual, okay, manual transmission. And then now we come to the shapes. The shapes is going to, remember, the shape represent the what? The number of cylinders, and the number of cylinders are also categorical. So these are the different shapes we actually want to give it. So giving it these shapes of what? 16, 17, and then what? 18. And that actually produce a different shapes for it. Again, we have under the labs, we have the title, comma, we have the X lab, X label, we have the Y label, we have the color, which is represented transmission, we have the shape, which is represented the number of cylinders. Again, we have the tune underscore classic, and then the tune, which is the plot dot title equal element text. So again, all this these layers add additional beautification to our plot. So let's go ahead and run everything. So now we are able to observe this, and then we can look at it. So now this is actually giving us a much better visualization where you can actually see the red is representing manual, right? So you can actually see that in terms of the relationship between MPG and then the weight, there is a kind of negative relationship between MPG and male, and then the MPG and weight. So in other words, the higher the level of MPG, the lower you might think in terms of the weight. But at the same time, we can also observe that the manual transmission tends to have higher MPG and then lower weights, okay? Because if you can actually take a plot and then plot, so these are the manuals, okay? And the manuals are the red. So the manual transmission tends to have high MPG and then it have low weight, okay? And that is also the same for, remember the circle also represents 4 cylinders. So with manual and 4 cylinders, they tend to have higher MPG and low weight, okay? And then this is the same thing you can actually say for, you can also talk about automatic transmission. So for automatic transmission, you can say that 8 cylinders, which is representing the diamond, happen to have higher weight and then lower MPG, okay? And then you can also, again, for each of them, the relationship in terms of MPG and then the weight is showing a kind of negative relationship, okay? And so this is how you can actually interpret, a plot of this nature. Okay, so now we can also create another scatter plot with annotations using the, how they call the hints data, okay? Which is pretty much similar to what we've actually just done. So we have the geoplot, our data, and then we are going to plot exercise versus BMI, okay? Again, BMI could depend on exercise. So our exercise have to be on the x-axis, BMI have to be on y-axis, and then the points, geo_points, we are going to be able to identify it using the color of the color equal the levels of the quality of care, okay? And then another, we are also going to be able to have geom_text, which we are going to have within the aesthetic. We said that give us the label should be the number of what? That's row names of the data and then adjust. So basically this actually also adding another layer that actually allows us to be able to properly observe this, visualization we would want to create. And then we have the labs, again, allowing us to know the title, the Y label, the X label, the Y labels, and then the color we are looking at is the quality of care status, and then we have the tune. Okay, so let's run this line of the code. Okay, so there's also a different visualization in which we can have. Now we are able to actually identify, so the observations, so within the data. So now we're able to know, maybe even if there's an outlier in terms of the relationship we are observing between BMI and exercise, maybe potentially the observation 574 could be a potential outlier we might want to further look into. Okay, likewise, so when we talk of outliers, we talk of values that distance itself from the rest of the data, right? Maybe observation 8, 34. So those are observations in which, maybe we might want to actually look further into, okay? Yeah, so this may not be that clear. Again, it's so hard to actually even read the relationship between BMI and then exercise for the various levels of the quality of care. But however, we can actually use a much looking at a different data set, which is again the MTCAR data set. we can perhaps have a better visualization, okay? Now, everything else is the same. Again, we are looking at the MPG versus the horsepower, and then we are coloring it based on the number of cylinders, and then these are the different, so the number of, we want it to actually give us the labels, okay, for each of the rows, to be able to identify the labels for each of the rows within, the data, in other words, observation, right? And then again, you give your plot the title, you give your plot the X label, the Y label, and then the color, what does the color actually represent, which within the color, we say the color should be the number of cylinders. So now let's look at it and run it, whether we have a better visualization as compared to the hints data. Okay, so now this actually gives us a better visualization, right? Now it's even able to identify, the different names, right, in terms of when comparing the horsepower and then the number of miles per gallon, it's able to actually tells us the different observations number, okay, and the names in which it actually represents. So we are able to know that, okay, this right here is looking at Toyota Corolla, right? This one right here is actually looking at Maserati Bora, okay? And so for a Maserati Bora, you can actually see it is having a very high horsepower, and then the MPG is what, around 15, okay? Corolla, we are looking at it's having a very high MPG with the horsepower being quite low. So the MPG is around, let's say, 33 or so, something, or maybe 34. And then the MPG is way out below 100. And the horsepower, the number of horsepower is below 100. Okay. So now we are able to physically even understand how the points, the plotted points for the number of cylinders within the plots looks like, whilst observing the relationship between horsepower and then the miles per gallon. And then we can see that the relationship, it looks like more of a negative relationship between horsepower and miles per gallon within the MT cars data. Okay, so now we can also look at some plots on time series, okay? You may not, if you don't know time series, we just basically looking at how we can observe how a data changes over time, okay? So now we are going to do that using a different data set, which we are going to use the economics data set from the ggplot2 package, okay? So we have to activate this data, and then we can look at the head of the data. We can look at the dimension of the data set, okay? So now we can actually we can plot ggplot of this economics data, and then we want you to plot a line plot of the date, okay? So this is the date versus the price, okay? And then you have to color it by the PCS, okay? Right. And then now we are going to use, before we plot it, the geo line allow us to be able to plot the line, to create that line plot or the time series plot, okay, of the date and then the employment, how they call it, the unemployment. So we are creating another line plot on top of this. So this first our data, we have the first line plot, and now we are creating another additional line plot on top of the first line plot in the same graph, okay? So we want two line plot on the same graph. So this time we are looking at the dates versus the unemployment, okay? The unemployment, number of unemployment, and at the same time, we want the the column to be equals to what? To be equals to unemployment. Okay. Then we create a legend of scale underscore color, which is underscore discrete, okay, which now we say the name equal legend. That allows us to be able to create legend name for the legend of the plot. And then now we have the title of the plot, which we can actually give using the labs function. So this function right here allows us to observe the legend. This function right here, which is geo underscore line, allows us to have another line plot embedded on the same plot. Okay. So let's highlight everything here and then let's run it. Okay. So now you can see the legend is able to tell us. So within the color, so the first color is represent this color here right here, which is it orange color, something like that, is representing the PS, okay? And then we have this one which is representing the unemployment, okay? So basically, we can actually see over the time period, if we are observing the prices over the time period for PS, we can actually see prices are rising for what? For PS, okay? And then if we look at for unemployment, we can actually also observe in terms of the number of what? The number of unemployment. Okay, and we can observe that unemployment have also been increasing over time, although there are times in which there was a very steep fall. Okay, so you just have to be able to observe it, but generally we can see kind of an increasing trend for both the PCS and then the unemployment. Okay. Okay, all right. So another thing in which you can also, another plot you can generate. Also, let us look at using a different data set, which will actually allow us to be able to compare scatter plots. So we are going to use a data called diamond, which is an inbuilt out data. We can look at the head of the data. So this is the data, and then we can look at the dimension. So there's a dimension of the data of over 53,000 to approximately 60,000. So from this data, we can actually generate a scatter plots of this diamond data by actually looking at our X, which is actually looking at the carat versus the prices, okay? So carat versus prices of the data. So, and then next, we are actually able to use geo underscore smooth, which allow us to be able to also observe the carat versus the prices with color of what? Cards. So we are able to, so there's the color which we are actually going to be able to observe, okay? So it's now going to be able to give us the distribution again, the relationship between carat and price, but however now it's giving it the relationship based on the cut levels, okay, which we have here. And then now we can actually label it, which is diamond data scatter plot of price versus carat, separated by what? The cut with smoothing, okay? The smoothing actually is kind of non-linear, it could be non-linear spline or non-linear regression line, which is actually drawn, okay? So let us run this. It will take some time before. Okay, so now we are able to observe this plot, which is actually, let us look at it very well. So now it is giving us the distribution, the relationship between price and then carat, okay, based on with the color for what? Cards, okay, which is fair, good, very good, premium, and then ideal, depending on the color. And then we are able to understand whether the smoothing allows us to understand whether it's a linear or it's non-linear, okay? So you can see that the yellow color, which is represent the ID of the cat, is very non-linear, okay? So in this case, usually this actually allows you to understand if you are building a statistical model, it allows you to understand, okay, maybe I have to use kind of a non-linear, build a non-linear statistical model rather than a linear statistical model, okay? So for all of them, the levels of the cat, we can see that the distribution between, the relationship between price and then carat seems to be non-linear. At least you can say that the fair carat seems a little bit linear compared to all the other levels of the cats, okay? Okay, and then you can also say that the distribution, the relationship tends to be positive. In other words, there is an increasing relationship. So positive relationship, so it means when the carat increases, prices tends to what? Increase. And when carat reduces, prices tend to reduce. When we have the lesser the number of carat, the lesser the prices, okay? And the higher the number of carat, the higher the prices. Okay, so now we can also create another function. So what we can do is, with all what we did, we can actually create a kind of a function in which we can actually call, okay? So rather than, and call it every time, okay? So for instance, I could have actually represented this entire ggplot by, let's say plot, okay? So I can assign it to plot. So in this case, if I run it, then now I can come and print plot. Plot, okay? So now if I print the plot, now it's able to print the plot for this whole function. So now we can actually, for ggplot, you can actually create a plot and place it just in one single variable, assign it to just one single variable and use it all the time. So now let us, using the diamond data, let us create a ggplot. So we are assigning it to gg, okay? And then we are saying that, okay, the diamond data, we are creating a scatter plot of carat versus price, but we want you to actually color it by the cat, okay? So in other words, identify the points in the plot by the cat, okay? And then also we have geopoints, which means the geopoints means it allowing us to generate the scatter plot. Okay, plus now we have our labels, okay? So we have the what, so these are different layers of the ggplot function. So we have the labels in which we have the labels as the scatter plot of the scatter plot of diamond data, scatter of what? Price versus carat by cat. The X label is the carat, the Y label is the what? Price. Then there's also another layer we can actually add, which is the theme, okay? We can decide to add, different theme in terms of the plot title, which we said equal element underscore text, okay? And then we have size equal 30, face equal bold. We have the X, the axis dot text dot X, okay? So these are different functions within, different arguments within the theme, which also add more beautification to the plot, and you are just trying to give it different, customizing your plot, okay? Now let us run this whole line. Now you see that once you run this whole line, nothing will generate, okay? So nothing will generate. Now we run it. So there is no plot generator, but then if we print GG, so now it's able to actually give us the plot. Okay, so now we are able to observe the plot of price versus carats. And then we are able to, based on the carats of the diamonds. Okay, And that's how you can actually create a variable for an entire ggplot you create, okay? And then we can also include something, some additional information, which is we would want to add. So once I have this function, I can go ahead and then add several other layers and to further customize my plot, okay? So what we are actually going to do, we are actually going to add some form of a grid, which we have the color being given by cat, okay? So what we needed is changing, which is the entire plot we create here plus the new layer we want to add, okay? So this is a new layer we just want to add, which is just create something new. Okay, so now this allows us to be able to actually generate different a grid of the relationship between the prices and then the carat, okay, for the different cuts of diamonds, okay. And now you are able to actually assess the relationship. So when the cuts of diamond is fair, you're able to observe the relationship between the carat and then the price. And you can see there is almost an increasing relationship between carat and prices for each of the levels of the cut of diamonds, right? So that's how you can actually also observe. Okay, so now this brings us an end to the multivariate visualization using ggplot, and there is so much to actually learn from ggplot, which give you a very great visualization. Okay, so I'll see you in a different lecture in the future. Okay, I hope you enjoy. Take care.